Welcome to Lesson 8B. We're going to continue where we left off, so we're just going to formalize and go over some of what we looked at in Lesson 8A, and then we are going to just do a couple of examples for Section 2.1, which looks at the derivative and the tangent line problem. So let's start with a quick summary from the activity that we did in our last lesson. The first thing we want to note is that the derivative is the slope of the tangent line. The second thing we want to note is that the derivative of f at x is defined as the limit as h goes to 0 of f of x plus h minus f of x over h, which remember is your difference quotient. Today we also want to take a closer look at our notation. So if you have a function f of x, then the derivative is notated as f prime of x. If you have a function y, then the derivative is notated as dy dx, which means the derivative of y with respect to x, or y prime. So just 4 quick examples for today. Here we want to use the definition of the derivative, or the limit process, to find f prime of x or dy dx. Remember, the limit process says that f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h, so our difference quotient. So the first thing we actually want to do is find our difference quotient. So we're going to plug in our x plus h, so we have 2/3 times x plus h plus 3 minus our original function, so 2/3 x plus 3 all over h. Simplifying from here, we get 2/3 x plus 2/3 h plus 3. Distributing our negative, we get minus 2/3 x minus 3 all over h. Canceling whatever we can, our 2/3 x and our negative 2/3 x cancel. Positive 3 and negative 3 cancel, so we are left with 2/3 h over h, and our h's cancel, which simplifies down to 2/3. That's the difference quotient problem you would have done before. To find the derivative, we want to take the limit as h goes to 0 of our simplified function, 2/3. There's nothing even to plug in, so that would just equal 2/3. So the derivative of this function, f of x, is f prime of x equals 2/3. So it's actually a constant function. For number 2, our directions stay the same. Use the definition of the derivative, or the limit process. So remember, f prime of x is equal to the limit as h goes to 0 of our difference quotient. So here we have a little bit more complex of a function. We have 1/2 x squared minus 2x plus 3. So again, just like in number 1, we're still going to start by finding our difference quotient. So we have 1/2 times x plus h squared minus 2 times x plus h plus 3. Subtract our f of x, so subtract our entire function, 1/2 x squared minus 2x plus 3, and that is all over h. Now we want to go ahead and simplify. Remember, the first thing we want to do is simplify our exponents. So we have 1/2 on the outside, x plus h squared turns into x squared plus 2xh plus h squared minus, I'm going to distribute my 2, so we have 2x plus, minus 2h plus 3, and then distributing our negative, we get minus 1/2 x squared plus 2x minus 3. Again, that's all going to be over h. Finally, we can distribute that 1/2 through, so we get 1/2 x squared plus 1xh, because you have 1/2 times 2, plus 1/2 h squared minus 2x minus 2h plus 3 minus 1/2 x squared plus 2x minus 3. That's a long string, so you just want to double check, make sure you copied all of the signs right. Hopefully I did. All over h, and now we can start to cancel anything that we have a positive and a negative. For example, our 1/2 x squared and our negative 1/2 x squared, our positive 3 and our negative 3, our positive 2x and our negative 2x. So lots of things are canceling. This simplifies down to be xh plus 1/2 h squared minus 2h all over h. Remember, now we can factor an h out of our numerator. So we're left with x plus 1/2 h minus 2 all over h. Now that we factor that h out, we can actually go ahead and cancel them. So this function simplifies down to x plus 1/2 h minus 2. Remember, from there we want to take the limit as h goes to 0 of that simplified function, so of x plus 1/2 h minus 2. Using direct substitution, we would get x plus 0 minus 2, which simplifies to x minus 2. So our derivative, f prime of x, is just equal to x minus 2. Okay, for number 3, same directions, still using our limit process to find the derivative. Just a little bit more exciting looking up a function. So the limit process, remember, we're going to take the limit as h goes to 0 of our difference quotient. So we want to start by actually finding our difference quotient. So our difference quotient would be the square root of x plus h plus 2 minus our original function, which is the square root of x plus 2, all over h. We've seen problems like this before. We have to think back to those techniques we learned in chapter 1, and to solve this problem, we actually have to use the rationalizing technique and multiply by the conjugate. So I'm going to multiply by x plus h plus 2 plus the square root of x plus 2 over itself, square root of x plus h plus 2 plus the square root of x plus 2. Remember that the numerator, you're creating a difference of squares, so what you get out is x plus h plus 2 minus x plus 2, because both of those quantities, when you square them, the square root goes away, over, and then our denominator is h times that whole quantity square root of x plus h plus 2 plus square root of x plus 2. Distributing our negative, our numerator becomes x plus h plus 2 minus x minus 2 over that exciting denominator, h square root x plus h plus 2 plus square root of x plus 2. Canceling whatever we can, we have a positive x and a negative x, a positive 2 and a negative 2. We're left with h over h times the square root of x plus h plus 2 plus square root of x plus 2. Denominator still just moving along. Now that we have just an h in our numerator and an h factor in our denominator, we can actually cancel those out. So we've simplified this difference quotient down to be 1 over the square root of x plus h plus 2 plus the square root of x plus 2. Remember, we are looking to find the derivative, so we now need to take the limit as h goes to 0 of the simplified difference quotient, so 1 over the square root of x plus h plus 2 plus square root of x plus 2. Using direct substitution, we would write this as 1 over the square root of x plus 0 plus 2 plus square root of x plus 2, which we can simplify down to be 1 over, there are 2 square root of x plus 2's in our denominator. And I'm actually going to leave it like that. So our derivative, now because we started with our function as y, we're going to write it as dy dx, which remember means the derivative of y with respect to x. And I'm just going to write this as 1 over 2 square root of x plus 2. Okay, we have our final and most exciting problem of the day. Here we want to again use the definition of the derivative, focusing on that limit process to find f prime of x. So again, we want to start by finding our difference quotient. To do that, remember we plug in our x plus h, so we would have 3 over x plus h plus 2 minus our original function, 3 over x plus 2, and that's all over h. So in finding the difference quotient, we've actually created a complex fraction. Remember, in order to simplify this, to get rid of those fractions inside fractions, we can multiply by our common denominator. So our common denominator here is actually going to be x plus h plus 2 times x plus 2. We're going to multiply by that over itself. Now when we simplify each piece in our first term, that x plus h plus 2 factor is going to cancel, and we're just left with 3 times x plus 2. Minus in our second term, our x plus 2's cancel, and we're left with 3 times x plus h plus 2. And then our denominator just stays the same, so we have that h, don't forget about it, times x plus h plus 2 times x plus 2. From here, we want to distribute everything that we can. So we'll start by distributing our 3. So we have 3x plus 6. Now distributing a negative 3, we get minus 3x minus 3h minus 6. And this is all over, again, that denominator, 3h, x plus h plus 2, and x plus 2. Canceling anything that we can, 3x and negative 3x, positive 6 and negative 6. So we're left with negative 3h over denominator of h, x plus h plus 2 times x plus 2. H's are factors in both the numerator and the denominator, so they're going to cancel. So we've simplified our difference quotient down to be negative 3 over x plus h plus 2 times x plus 2. Because we are looking for the derivative, we want to take the limit as h goes to 0 of that difference quotient, so negative 3 over x plus h plus 2 times x plus 2. Using direct substitution, we get negative 3 over x plus 2 times x plus 2. And we can simplify that. X plus 2 times x plus 2 being multiplied by itself is really just it squared. So we can write our derivative, f prime of x, is equal to negative 3 over the quantity x plus 2 squared. Great job with your first day of derivatives. Homework number 8 is short, section 2.1, which is on page 103. You just have these 5 problems where you are finding the limit or finding the derivative using the limit process. So numbers 11, 14, 17, 21, 23. If you have any questions, please feel free to reach out to your teacher.